Okay, we're going to take a look at 2010 free response question 4 through 6. Okay, so looking at this question here, question 4 is the one with the car models. Taking a look at the rubric for part A, there's two components that they're looking for. Calculating the expected number of owners, showing a proper method and the proper value, and then same thing for the standard deviation. Recognizing that it is in a binomial distribution. The key thing being there, expected number. We only use expected number for chi-squared or binomial, so, and we have quantitative data here, so it's going to be the binomial distribution. Okay, so as I've talked about in class, we're talking about Bernoulli trials. I think I mentioned it's hardly ever been on the rubric, but you'll notice I didn't talk about them. Let me just verbally go through that. So there's three components that need to be met. One, there's success or failure, so you own model E or you don't. Two, the probability of success is constant. And three, each trial is independent of one another. All three of those are met, therefore these are Bernoulli trials, therefore we can use the binomial probability model. These formulas are on your green sheet. Nice thing is, too, it tells you the two parameters, n and p, number of trials, probability of success. Here's the mean, n times p. Here's the standard deviation, square root of np times 1 minus p. So that's what you're going to see me use here in my calculation. So when I'm defining my random variable, x is the number of model E owners out of 2,000. I have to have out of 2,000. That's what makes it binomial, not geometric. Also, I'm missing part of what else I should have. I should have, I'll write it in now. X is binomial, and my two parameters are n, 2000, and p, which ends up being approximately 0.0078 when I divide those two. Okay, so n times p, 15.62 people approximately. I'm not rounding to the nearest person. Standard deviation, about 3.95 people. Your answer may be a little different if you didn't use these exact fractions. Should be like 3.7, 3.8, 3.9, somewhere in that range. Okay, I have the correct calculations and numerical values for part A, so both of those components are met. So that's going to be an E. As I move down to part B, how likely is it that fewer than 12 owners of model E would be included in the sample? All right, so essentially correct if they do any of the following. You can use the binomial distribution and calculate your probability that way. Use the normal model. You'll notice I did that. And provide an argument based on a z-score without actually going further and getting that value. So in order to use the normal model as an approximation for the binomial model, you have to check the success failure condition. So n times p, we already did that in part A. So that was the 15.62. N times q over 1900, both of which are greater than or equal to 10. That means I can approximate the binomial model with the normal model. So calculating a z-score, about negative 0.9. Do some norm CDF from negative 99 to negative 0.9 to get about 18%. Depending on rounding and things like that, I know some of you in class are using the binomial distribution and you're getting around 14.7%. You're still going to earn essentially correct here. So that's going to be essentially correct. Let's take a look. I'm not sure in the rubric if they show you the binomial way. Yeah, they do. Okay, cool. So here, they're not writing out the three formulas, they're just showing the summation. And there's that 0.147 I was talking about. So let me just kind of talk through this. If you did this in your calculator, you're going to do, not 1 minus, you're going to do binom CDF, number of trials on 2,000, probability of success, and number of successes. Okay, we want it fewer than 12. So I want to sum up 0 through 11. That's going to give you that. All right. Okay, so that was essentially correct. Moving to part C now. Okay, I need to ensure that I get at least 12 owners of model D and 12 owners of model E. So for all 5 car models, but specifically D and E that they're worried about. So I need to think about what kind of sampling process would guarantee that I'm getting some of every model. Well, I'm thinking stratified cluster. The issue with cluster is if I pick a couple clusters, say I pick A and C, then I'm randomly sampling everyone in A and C. So that would be a census and I wouldn't get any model B, D, or E. So that's not going to be correct. If you have cluster, it's automatically an I. So But I said I'm going to stratify the owners based on the model and then randomly sample owners within each strata, A through E, selecting the number of owners proportional to the percent of cars of each car sold. So essentially, there's way more people who bought Model A, so out of my 2,000, I should sample a greater number. So say 40% of people bought Model A, then I need 40% of my 2,000 to be Model A from my random sample. So you'll notice I calculated the percent multiplied by 2,000. So in this case, it's actually 756 owners for Model A should be randomly selected. And then you'll notice I said I'm going to repeat the process for each strata. It's not, I don't need to go through it and show those actual calculations. Taking a look at the scoring rubric. Okay, you'll notice, and maybe I should have done this, they talk about the specific number for each. And maybe I'm going to find out that I'm going to get a P instead of an E. All right? So let's look at the grading here. There's 3 components that they're looking for. Ensure that your total sample size was 2,000. So, yeah, you know what? It's kind of vague. I didn't really put that in there, so I don't think I met that criteria. At least 12 owners in each of the 5 car models. I didn't follow through enough to, let me bring this up here. I didn't follow through enough to show that I have at least 12 in each of them, so that I didn't meet that criteria. But I do have random selection of owners. So I met one of the 3 criteria, so that would be incorrect. So you can see how easy it is to, that I knew what I was talking about, but I did a poor job communicating it and didn't follow through. So this is going to be I. This is going to be incorrect. So I have 2 E's and an I. There's only 3 parts here. So 2 parts essentially correct and 1 part incorrect. This would represent a 2. So there's your question on it. It's a little bit of a mix. We have some probability in there. We have some experimental design and sampling in part C. Okay, let's move on to question number 5 and take a look at what we have there. So question 5, here's your inference question. Full on, convincing evidence, mean, I see length of fish, okay, inches, I have units. Okay, so I have quantitative data, I have 1 variable, just the length of the fish, I have 2 samples. I need to think about, are they independent, are they paired? Well, I have fish from Byrate and fish from Fish Friends, so I have 2 independent groups. So this is going to be a 2-sample T test is what I'm going to be looking at doing here. All right, so taking a look at the rubric. Let's see if they went E or E and I or just EPI. Okay, grading. Okay, each of the 4 steps is E, P, or I. So again, generous, that's not the norm. Usually it's just E or I. Okay, so step 1 is going to follow along with step 1 of your test. That's going to be your hypotheses. So looking at the hypotheses here, for means, your parameter is always going to be mu. So mu of fish rate minus mu of buy rate is 0. Then here the difference is greater than 0 because they said in the context, Fish Friends is it greater than that of buy rate. Okay. So taking a look at the grading, it's essentially correct if you use the correct parameters and has the correct hypotheses. I have both of those things. I'm good to go. This would be essentially correct. You could also have mu sub f equals mu sub b, and mu sub f is greater than mu sub b. That would also earn essentially correct. Okay, step 2. We're looking for 3 components in order to earn essentially correct. The test name, checking for independent random samples, so independent groups, and normality. So here, stated random samples, they stated that in the stem of the question. But that's not the independent random samples. I'll get to that in a minute. I'm going to assume that 1 fish weight or 1 fish length is independent of another. 10% condition, definitely less than 10% of all fish at each place. This is the independent random samples, independent groups. I'm assuming the groups are independent. The nearly normal condition, I had to plug the data in my calculator, create some histograms, labeling them. So I'm noticing right now that I left off part of what I should have said here. I need to talk about the histogram as being unimodal and roughly symmetric, therefore the central limit theorem is going to apply. I did not do that. Conditions met. I'm going to use a t-model, degrees of freedom equals 16, getting that from the calculator for a 2-sample t-test. So let's look specifically at their solution and see if I did enough or not to earn credit with my nearly normal. Okay. The following dot plots reveal no obvious departures from normality, so it's reasonable to assume to proceed. So I didn't really communicate that at all, so I really don't think that I did that part. So therefore, I'm not going to get credit for checking for normality. I checked, but I didn't really finish and communicate that they were or were not normally distributed. So in this case, I did 2 out of the 3 components. That's going to earn me a P. Okay, step 3 is looking at the mechanics, and let's see what they're looking for here. 2 things. Correctly calculates the test statistic and p-value. All right. As far as running out of time, making things up, here you go. If you have a p-value, oh, that's for next step. Ignore that. All right. So, difference between the parameters is 0. Difference between the sample means is 0.06, and they were nice enough to give us. Let me just not hit that. The data here. The summary statistics, so I just subtracted those to get the 0.06. Let me fix this. All right. T was 16 degrees of freedom. I just did a 2-sample t-test in the calculator, plugged in this information. My standard error is coming from my formula sheet here. 2-sample difference in means. Again, we're never using this. We're never pooling for means, just for a 2-proportion z-test. So that's where you'll notice my denominator. So my test statistic is 0.25. I have a sketch. And my p-value is 0.4. So I have a correct test statistic. I have a correct p-value. This would earn me essentially correct. Just double checking on the rubric. All right, you'll notice here they have a negative test statistic because they did F minus B. Or I'm sorry, they did B minus F. I did F minus B. That's why we have the difference, but the p-value is the same. Okay, step 4. We need a correct conclusion in context. So they're looking for a couple things to earn credit. Correct conclusion in context and linkage between the p-value, as always. So again, if you're running out of time, you're doing 2 things. You're writing your null and alternative, getting a point there. You're making up a p-value, and then you're writing a conclusion. So let's take a look at the conclusion. Okay, so since the p-value, the 0.4 is high at the alpha equals 0.05 level, we're going to fail to reject the null. There is weak evidence. And I'm going to just use the context from the question again. Right? There's weak evidence that the mean length of adult fish from fish friends is greater than the mean length of the adult fish from by right. That's literally pretty much word for word what I said here. Okay, I have linkage, I have it in context. This is essentially correct. So I'm looking at, I got 3 E's and 1 P. Again, you're in the middle, that's 3.5 points. Almost always is going to be rounded down. So I'm going to be looking at a 3 on this question. Okay, moving on to question 6, which you were working on today in class. All right, part A, it's kind of unique. You're trying to sketch a graphical display. It's unique in the sense that we have quantitative data. We're measuring the hurricane damage in dollars per acre. And we have categorical variables. We're looking at the distance from the coast and the 3 coastal regions. So because I'm specifically graphing the damage, the graphs are histograms, but it's not what we're used to seeing. So let's take a look at the rubric as far as what I need to earn credit. And this is broken up into 4 sections. Section 1 is just part A. So it's essentially correct if you have a well-labeled, statistically valid graph that allows for comparing damage amounts both across regions and at varying distances from the coast. So I believe a line plot would be appropriate here as well as our histograms. Segmented bar graph would not work. It's not a bar graph, and there's no way to segment these. So Okay, I have my three regions here, coastal regions. I have a key. G is Gulf Coast, F is Florida, LA is Lower Atlantic. I have the distance from the coast. I probably could have added some units there in miles. That would definitely be something you'd want to do. And over here, I have the damage in millions per acre. And you'll notice that I have the 5 different regions listed here. So let's take a look at specifically what is going to lose some points. Okay, well labeled. If you don't have it labeled, you're going to be getting incorrect. So if it's poorly labeled, right away incorrect. That's something very simple that you can't afford to miss points on. All right, it doesn't say anything specifically about the units for miles. I don't like it that I forgot it, but you'll notice here on their key they show that. But it is labeled distance from coast, so I believe I have enough information to warrant an E for part A. Let's take a look at part B, describing the similarities and differences. So you're thinking about cost, you're describing a distribution, but it's not a typical distribution that we're seeing, that we're used to seeing because of the quantitative and categorical variables here. So essentially correct if it includes both. We need to mention a difference between the 3 regions, and they give an example. Florida has the greatest damage. And then a mention of similarity. We're looking at a similarity and a difference. The similarity is as the distance from the coast increases, the damage is decreasing. All right, so taking a look at what I wrote up here. If I can find my paper, here we go. Okay, for almost every distance from the coast, Florida has the greatest amount of damage. So that's me talking about what the difference is. I wish I had worded this a little bit differently, but typically as the distance from the coast increases, the amount of damage decreases. That's pretty easy to see looking at my graphical display. And the Atlantic region almost always had the least amount of damage. So I mentioned the difference. Florida had the most, the Atlantic had the least, and the similarity that as the distance increased, the damage decreased. So I've done both of those 2 things. I've earned essentially correct. Again, your goal is at least 1 point here. So this is earning me 3.125 points towards my composite score. Same for every single point you earn on question 6. Okay, part C and part D. This is where to kind of throw some awkward stuff at you, like, oh, this should be the easiest question ever on an AP exam. You're just trying to assign ranks. So all I'm doing is looking at the data. Florida had the highest damage, Gulf close second, Lower Atlantic third, and I'm averaging. Literally, add those up, divide by 5, same thing for each of these. All right? They're clumping C and D together here because that was so simplistic. For D, they ask you to calculate a test statistic, and it's pretty straightforward what they want you to do. I need the mean for the Gulf Coast, the mean for Florida, and the mean for Lower Atlantic. So I'm just going to substitute into that formula using my answers from C, do a calculation, and get 6.4. So as I look at section 3, it's essentially correct if you have the correct ranks and the correct test statistic. Partially correct if you have the correct ranks but you messed up the test statistic, or you have wrong ranks but you've followed through correctly. So worst case, you should be getting a P here. All right, so C and D together, I've done both of those parts properly. That's going to earn me an essentially correct. Part E, love this question. Like I said to you in class, they are asking this way more on the AP exam lately. It's a simulation done to kind of come up with a p-value where you need to write a conclusion based on that p-value. Okay, they're looking for 2 things. 1, a veiled quantification of the tail probability of the test statistic, and 2, a conclusion in context talking about the test statistic relative to the simulated values. So let me make some sense of that for you. First, you need to think about p-value in context. It's if the null is true, what's the probability you see something that or more extreme? Well, our test statistic was 6.4. So that or more extreme is going to be 6.4 or more. So if I sum those up, I get 39. So it happens 39 out of 1,000 times. If you think about this as a distribution here, okay, this is my test statistic, 6.4. If I have a distribution, it kind of be like chi-squared, skewed to the right here. I'm going to be shading over here. That's where I'm getting this p-value from. That or more extreme happened 39 times out of 1,000. So that's where I'm getting that p-value. All right, so now I'm just going to write a conclusion in context since only 0.0039 of all simulated values fall at or above 6.4. This is low with alpha equals 0.05 level. So I'm going to reject the null. There's strong evidence, and then I'm going to utilize some context from the question here, that there's strong evidence that there is a significant difference in the distributions of hurricane damage amounts among the 3 coastal regions. Okay, so they're looking for 2 things, the tail probability and then a conclusion in context. I've done both of those things. That's going to earn me an E. 4 points here. Each E is a P. I'm sorry, each E is a point. P is a half a point. If you end up in the middle, round down. I got 4 E's. That's going to earn me 4 points. Which 4 times 3.125, you're talking about 12.5 points that you just would be earning for your composite score. Okay, hopefully you guys found these helpful, and we'll see you next week.